I want to thank you all. My name is Miloš Vorkapić, and the topic is thermomechanical rates of additive manufactured carbon fiber reinforced PLA. In this presentation, I will talk something about additive manufacturing and about our study and our goal of this presentation of our experimental work. We use 3D printer type Bamboo Lab X1 as main printer for our samples, and we used polyelastic acid PLA as a commonly used biodegradable material. It is thermoplastic polymer, very cheap in the market, for instance, and very known for everyone who works with 3D printing. Our study objective is to investigate thermomechanical performance and to find the difference between PLA and PLA CF with carbon fiber particles. It means there is a composite with carbon fiber particles. In our experiment, we can focus on tensile strength, impact toughness, thermal resistance, and that was all in correlation with 3D printing orientation. We manufactured samples in three orientation: X orientation, first orientation, second orientation, X-set orientation, and the third orientation is in Y-set orientation. In our investigation, we used, as mentioned, PLA, 3D printer I told earlier, and we prepared our samples. It means, as mentioned the colleague Alexa, very important parameters when we want to manufacture our samples. It means layer height, ethyl density, or we call that raster line. For example, we used as layer height 0.1 millimeter and ethyl density of 90%. What is the meaning of these two parameters? These two parameters are very important. For example, in this case, we know, it is very known in many literature sources that every manufactured sample is not homogeneous material. It is anisotropic material. It means that we have a lot of holes, and it is porosity. It is a great porosity. With this ethyl density of 90%, we talk about approximately two homogeneous material. In test conditions, we made 27 tensile samples and 27 impact samples. We measured, and in this test, with three temperature testing, in temperature about minus 30 degrees, in plus 20 degrees at simulation room temperature, and in the higher temperature as plus 50 degrees. In this characterizations, we used techniques. That means tensile testing, input testing. After that, to scan our material structure to find what happened with the material. We used the DST method and TIR method. These are the images of the pairs, and it was very important. We used 9 samples or specimens. It means they are prepared series of 3. It is 9 samples. It means 3 samples from each temperature. Earlier, someone mentioned about moisture, about to colleague Alex. It was the same thing. We measured at the same time and prepared our samples at the same time for measure. Because we didn't talk in this our experiment about aging, and our other and future work about these samples will be conducted to aging, thermal treating, other thermal treating on this, or to prepare to find and to test durability, for especially extremely low temperature. In that case, we will talk about durability in liquid nitrogen. It is very extreme temperature. And this is free radiation. We free radiation, direction, except direction for the tensile test and for input test in free radiation, how we manufacture in Bamboo Lab our samples. Results are well known, and mean values from three measurements with standard deviations means that we use that average values for x epsilon, x set, and epsilon set values. And as a conclusion, our material in the cooperation with the row or the basic or the material PLA, but PLA with carbon fiber particles show that the highest input darkness is X-set orientation. But the best results in our experiment are on the highest temperature, about 50 degrees, in the all three orientation. It means that kind of orange color in that. On the tensile test results, you can see the youngest model of elasticity. The best is on the lowest temperature. Why? You will see in the next slide pictures, because that in this area, in this temperature, was brittle fatigue. It means that in cooperation with the fuel or the raw PLA, we have on the normal, on the room temperature, about 20 degrees, we have 2.43 kilopascal module, 2.12 and 1.85 in correlation approximately to the orientation, specimen orientation, are more higher, or maybe twice. For example, for pure PLA, they were in literature, they told that for a pure PLA is between 0.98 to 1.97, approximately, in that border conditions. This is some presentation in stress strain curve about room temperature or about 20 degrees, and the best results are in X epsilon orientation, and we call that specimens no treatment. Why? Because that is a room temperature, and in that combination we have low temperature as minus 30 degrees, and high temperature we call about plus 50 degrees. And the worst results are in epsilon set orientation. And this is the samples before and after input test, and for tensile test and for input test. On this picture, upper right, you have a brittle fatigue, and this is why is the connection with table where the values of the Young's model elasticity are so high. When we talk about these results, we have here three temperature. This is the first temperature about specificity, melting temperature, and temperature degradation. Very important for us, and in this cooperation with PLA, with carbon fibers compounds and the PLA raw material, we have that the temperature are higher when we talk about PLA with carbon fiber particles. Why? Because that higher temperature means that the PLA with carbon fibers have a better thermal stability than pure PLA. That is very important. What happened with material structure, and this is one of the main conclusions about what the purpose of how to use and how to PLA carbon fiber to use in other applications. In this means, peer spectra, also comparing PLA, pure PLA with PLA with carbon fiber particles. And in this area, we see similarity between PLA and PLA with carbon fiber particles. But this fix only in the left side means hydrogen groups, and they are more specific from PLA carbon fibers. But the difference between these two diagrams are on the right column. It means that this is the mean and the influence of carbon fiber particles. One of the problem in this investigation, and we didn't mention it here, and it is some kind of secret to bubble up filament specification. We didn't find percent of carbon fibers compounds in that composites with PLA. Many literature sources talk about 15, 30, 45% of present carbon fiber particles in PLA. In this region, carbon spectrum region indicates potential bonding or interaction. And this is why it is important and why it is important carbon fiber in this combination with PLA. As a conclusion, we didn't mention in the beginning, but we talked about layer height, we talked about intensity, input pattern. We use lines as input pattern. We use line direction minus 45 degrees. It is obviously the best orientation. Printing temperature used as mentioned as specification of material 255 degrees, and the build plate's temperature about 55 degrees. But the first time we printed with extreme, some kind of extreme speed, about 200 millimeters per second, because early generations print with 50, 60, and 80 millimeters per second. Maybe these print speed it has significant significance in results. As manufactured PLA with carbon fibers are promising material in these conditions, but in future work, with investigation of long term, we will find and we will try to talk about durability, about fatigue resistance, and other investigation. Thanks.